Good afternoon to all the participants for today's hands-on session. So this hands-on session will be again conducted by our Abdul Raheem sir. So no, I think no need to introduce now the Abdul Rahim sir. You all well known to him. So now I directly, without wasting the time, I hand over the session to Abdul Rahim sir. Now I request Abdul Rahim sir to carry the things further. Over to you, sir.
Thanks a lot, sir.
Yeah, sir.
Okay, sir, I'll take over the session and we'll have an hands-on session on machine learning with some different implementations. Today we are going to learn different things also.
Okay, sir.
Good afternoon, everyone. We will have a hands-on session on machine learning in today's session, and we will be implementing some two of the projects that I have built on, and we'll be working on those projects because in today's session we have to start implementation of machine learning with few of the projects. Okay, one of the project that we are going to build for today will be a face recognition system by using a pre-trained model that we basically call it as a cafe model. By using the cafe model, we can already the number of what kind of images there should be and what lines, what vectors, and all the geometrical figure of a human face has been already written in that cafe model, and we'll be starting our implementation of face recognition system in machine learning by using Google Colab. So first of all, we need to understand what is face recognition system and what is the importance of face recognition. And before going to that, we need to understand what kind of applications we can build by using face recognition system, because we must be very curious because we are learning some new things. Then we should be also knowing that where we can implement these kind of applications. So first of all, we are going to have uh, the applications where we are going to build face recognition system is preventing some sort of retail crime, where we can make a note of, we can take the biometrics, face biometrics of the prisoners, and we can save it into the into some sort of database, and we can allow whenever if some sort of things are going in different area, something like a public area, if the prisoner is roaming in the public area, suddenly just by recognizing the face, we should get a notification that the prisoner is somewhere out on so and so location. So we can do this kind of a project also. This is also a good idea by using face recognition. And one more basic thing, we all know that we are using smartphones, and many of the smartphones do have the face unlock system. Just by recognizing your face, it is going to understand how we are going to the whole biometrics is being taken by our phone itself. And one more good idea that we can implement for face recognition system will be for finding the missing persons. Suppose there are a lot of missing childrens, a lot of missing persons, where where they can be viewed in the public places, something like railway station, bus stations, and airports and all. So at that point of a view, we can allow the users, I mean, to the cameras itself, to detect the face of the missing persons and directly inform it to the family of the missing person with a notification, or to the nearby police stations or anything. So we can have this one sort of uh, application also, and we can even build a uh, application which is going to help the blind people. Then how, suppose if someone is smiling, or if someone is crying in front of the blind people, so they can just check out with the mobile phones, and the mobile phone is going to get vibrated, and through that vibration the blind person is going to recognize. Suppose if he is smiling, then single vibration. If he is crying, one or two times of vibration, two or more times of vibrations of the mobile phone. So we can add this kind of a thing in our mobile phones also. And we can add this into our forensic investigations for our for protecting our laws and all, by allowing our police department, CIDs, so they can directly, just by watching the face of the camera, within the camera, it can be it can be very easily notifiable directly to the person who is investigating. And one more best idea that we can do is, we can make the people to be identified on whether they are real or not. Maybe we have got some sort of issues with whether the celebrities or the VIPs are, whether they are real or not. So they'll be having some sort of protection, security related things. So we can analyze and we can allow whether the VIPs, it may be politicians, it may be, or high profile designators. So we can identify them just by using the face recognition system. And one more thing, we can even identify the person who are on social media platforms also. Suppose many of the issues right now, we are getting a lot of issues regarding um, fake IDs that are being created in social media. So we can make sure that even if you people have used Facebook, then suppose if I have taken one of the images with one of my friend who is already there in the Facebook, then automatically the viewer who is viewing the photo of mine is going to get the name of my friend also automatically. So this is done by the face recognition system built by Facebook or any other social platforms also. So they can even add their own social media platform, this kind of things, like speaker recognition, whether the user is himself or not. So likewise they can make the viewers not to be in a confused state, so that whatever data they are coming from the celebrities, from the politicians, that can be that can be a genuine data, so that the the viewers can get the clear data. And we can even diagnose diseases. There is one of the rare disease that can be detected by the human face, Dijor syndrome, which is going to keep on increasing and decreasing your face lifts. So because of that, we can even allow the users to check out whether the disease is present or not. So we can allow the face detection also to do that. And we can even allow face detection or face recognition surveillance system in schools also, where some expelled students or some drug dealers or some dangerous parents also, or some other unwanted people who are coming into the schools and all for creating messes. So at that time it can recognize, and we can apply that to the the door system of the schools, where the door will not open if the person is being founded as suspected. And the very simple thing where we can also track the um, school attendance, and some sort of, even in the banking process also, if you are trying to do some sort of transactions in the banks regarding where the amount is more higher, something like if the amount goes on increasing with more money than 5 lakh rupees, then the surveillance should do some sort of facial recognition, biometric recognition with the user, where there will be no fraudsters, and no fraud will be done with the banks. So all these things, and suppose even if we are trying to find out our pets also, if our pets are being lost somewhere and being found in different areas also, at that time we can use these facial recognition system. And for drivers and many more examples I can give. So as we don't have much time for this session, so this is, I guess, enough, where we can get some clear kind of an idea, where we can directly implement such kind of a project and allow the user to allow the user to be detected easily. So this is one of the thing, and we'll just start the implementation of our face detection face detection project. So first of all, we will be using some sort of different kind of modules before implementing. So there is imutils. We need to add imutils. Imutils is basically used to for image processing itself, where it is a library which is going to allow us to add the series of convenience functions to make our basic image also into the processing functions. Something like, if we are trying to do translation of the images, or we are trying to do some rotation, resizing, or skeletonizing the images, or displaying the images with different kind of libraries like OpenCV and all. So we can add imutils. And anyhow, we all know NumPy and CV2. CV2 is a great tool for image processing and performing computer visioning tasks. So we can add this, and this can be downloaded by, if you are using into our local machines, we can directly use this as um, pip install python opencv python dash opencv python, and just by using that one we can implement our uh, we can download our opencv and we can start working on the project. And the next thing that we will be, the next library that we will be using will be for IPython. IPython is basically used for interactive Python, where a Python shell is provided to display our JavaScript, as well as if you are trying to make some sort of opening window, or we are trying to write some sort of buttons like something like to open window, to capture, or to capture image, to capture video. So this kind of basic JavaScript import will be done by using IPython. And we'll be using eval is also one of the uh, best library that we can use, which is already inputted into our Google Colab.output library, and this is going to allow our library to evaluate with the overall JavaScript expressions that are present. Okay, so once we are done with this, we will be using, we need some sort of encoding and decoding methods. So encoding in the sense we are going to capture some sort of images, and to those images we need something, we need a library where it is going to allow us to encode the images as well as decode the image. So so this is all about the modules that we are going to use in IMU in our face detection. And first thing that we'll be importing is imutils. This is going to allow us to create, to rotate, to crop, or to resize, or anything. All the functionalities will be done by using this imutils. And import numpy as np. I'm just short noting numpy, and import cv2. This is computer vision 2. This is the latest library that they have provided for cv2, where we can allow all the image processing things to be done over here. Okay, and after OpenCV we need from google.colab google.colab.patches. We need something like where we are going to allow the user we are going to allow some sort of images to be displayed whenever it is called. So for that they have provided a built-in function, that is cv2 imshow. This is the latest version that we are using, and within this they have provided to watch out our images, or to watch out the images with the extracted data, or whether the detected faces and all. For that reason we are going to add cv2.imshow. And again from IPython, that is interactive Python dot display. I'm trying to fetch it by using the JavaScript, so that's why I'm using this library display comma JavaScript, because we need JavaScript to capture images. So that's why I'm using this IPython dot display import display JavaScript. And after that, from google dot collab dot output, I need something that is going to evaluate the JavaScript that we have written. So we'll be using eval.js, which is going to evaluate our JavaScript that we have. We are going to write it in the Python code. Then after this, from, as I said, we need some library that is going to allow us to encode and decode our image into binary or binary code. So for this we have base64 library, import v6 for decode. So this is the library where we'll be allowing to decode our images. And first let me just check out by executing this one, by running this one, so that we'll not get any sort of error over here. Okay, here we do have an error. IPython.display cannot import name JavaScript. Okay, I have just mistaken this, and we can run it again. If our modules are not being loaded correctly, then the further execution of the project will never be going to work, because we need to first load all the libraries. If the libraries are not being loaded, then we have to install it, then we can go for executing the next line codes. And here this is displaying 0 seconds and this is being executed. I'll take one more code cell where I'll be defining a function where it is going to take and turn on our webcam and take images, take photo file, and I want that this photo to be saved, so that this photo is going to work and display the face recognition. And this should be whichever it should be named as photo.jpg, the image. Whenever I'll be opening a camera, when I click on a button, and that image should be saved as photo.jpg. And I'll show you. You can see over here on the left side, we don't have anything over here. We don't have any images that are being saved, nor even in the sample data also. So we'll just save it over here itself. And after this, we want that the quality of the image quality should be 0.8 pixels. I'll be giving it in a way of pixels. And after this, we'll be taking our JavaScript, which is going to open our JavaScript. And to this function, we need to give something like this, and giving an enter. 1, 2. Okay. I want that indentation should be working fine over here. Asynchronous function take photo. Asynchronous function take photo, and this quality we are going to mention it. And over here I'll be trying to open my webcam with a few of the constant variables, and that variable should be stored within a division, and those divisions should be having some if we are familiar with JavaScript, then we may know that this can be done by using document dot create element, or we can display it by using even by document dot get element by id, document dot create element. So in this way we are trying to create a window where the webcam will be open. For that I'll be taking one constant division, HTML division, where document dot create element. I am trying to create a div now. It should be div, and again constant. I'll copy the same thing, copy this and Control V, and this time I'll remove this and say capture, and this time I'll be creating a button called capture. And now I am trying to open some sort of division, and I'm trying to I'm trying to open a division, and within that division I'm trying to write, and I'm trying to open one button which will be named as capture, and to this capture I'll be assigning capture dot text content. What will be the text content? So to this button, we are trying to write the content of the button, like what name should we give uh, to the button. So over here I'll be saying take photo. I'll write take photo on the button as a button name, and to this I'll assign this to the division dot append child, and this will be assigned to our capture constant variable over here. So we are done with this. We need some sort of more things to be writing, like what will be the size of the window of the opening, and what will be the size of the, how much pixels it should generate, and how much what kind I need to assign some sort of CSS to this one, so that it will be opening in a. So I'll be saying that constant video equal to document dot create element. A video should be, if you are trying it for a video, then a video should be open. And to this video streamer, when the webcam is being opened, I want to style dot display. I'm assigning the CSS for this one. Style dot display equals to block. This should be of a display of block, and to this constant streaming, like how much this should stream. Await, I'll be taking the await function, await navigator dot media devices. The devices that we are going to use. If you are trying to run this on mobile phone, then it can be this is going to allow us, media dot devices is going to allow us to integrate the front camera of mobile phone. If you are trying to use in a tablet, always the tablet front screen. So after this, I need that this data should be get user media. To this user media, we'll say video will be true. If I say it false, then this will stop taking the images. And then after that, Then after this, we'll be taking the video. It should be displayed within the the division that we have created. So document dot body dot append child, it should go into div tag, and this division should append child, and within this I'm trying to open the video video and video should be streaming. This is the basic video tag that we are going to use, video tag, which will be having an src in our uh, I mean uh, in our uh, HTML. We are going to use this kind where src is nothing but the source object where we'll be streaming our webcam video. Stream and wait until video is being played. Video play. And if you want to resize, we have to resize so that if the video cam is being opened in the whole screen, then there will be no exit button. So that's why I'll make sure that it should be set out within a frame of google dot collab dot output dot set iframe, the height of the window that we are trying to open. We'll set out the height of our video length. Document dot document element dot, we'll make this as a scrollable height. This should be true. Scrollable height, and this we are saying that try to turn on the scrolling bar to be visible on even though if the video is playing in the background, and await new promise. We'll say resolve an arrow function. We'll be using capture on click. So I'm trying to write an on click function over here whenever the button is being pressed on the take pick. So at that time we will be having directly we will be having to take that image and store it there itself. Resolve and enter, and few more things so that we can adjust the width and height properly. So I have taken over here await new promise. Okay, I can make sure that a canvas, an HTML canvas can be a good thing so that we can open canvas over here. Canvas equal to document dot create element, where a canvas will be opened and it will capture our image that we will give. enter, and the canvas width should be canvas dot width equals to video dot video width. And height, same thing, I'll just copy it. Height, and over here height over here. Then what kind of a context it should be displaying? Either it can be a 2D, 3D, so we can decide it with the same thing. Canvas dot get context of 2D array, 2D, and we will be drawing the image about this. Draw image video, comma 0, comma 0. And we'll take some sort of streaming video tracks dot get video tracks of 0, and it should be stopped. And after that, remove the division that we have created. Div.remove, return canvas dot to data URL, and this should be of a type of image slash JPEG, and it should return even the quality of the image. So we'll end it over here by saying that this should be executed where we are trying to get and get tracks. Okay, all the things. Okay, over here I need to mention 1, 2, 3. And to this, now we will say display our JavaScript, display our JS function that we have written above, and data equals to, now we want to evaluate eval dot underscore JS, where this is going to allow the JavaScript that we have written above to directly display within our machine learning function. Eval JS take photo This is the take photo function that we have written above, for format with the quality, and enter. Now we want that this binary value, that the image that we are going to take, it should be displayed and converted into decoded directly into our binary format. B6 decode of the data dot split function with the comma with the indexing value of 1. With open with function open file name comma wb as f, and within this we'll be writing f dot write open our binary file that has been saved. Here it is saying when this is being decoded, when this B64 decode is done, this is going to display it in the binary format, and we are saying that it should be saved in a file name called wb, and we are saying it should write the binary format within that file and return the file name. That's it. So this is where we have created our file name to be displayed, and let me just check out if we have done any sort of okay, this is working fine. It means that we haven't done any of the mistake in this function, in the writing of the function. And within this we will be adding one more cell where now this is going to fetch image file. This will take my photo now. Take photo. And if I run this one now, this should take and start my webcam now. Okay, here it is. So this has started my webcam now. And here we can see there is a button. Okay, I guess we got some error. Canvas.get context is not a function. Okay, it is get content. Get content. We'll execute this again. And rerun my file again over here and rerun the image file. It is working on the webcam. I got any of the issue over here. I think I should run it all in once. This will take some amount of time to load our JavaScript and create a file and store that file with the name of WB. This should not take so much of time. Collab reply. Keyboard interrupted. Okay. Okay. Eval.js. Let me just try to change the names. Runtime run all. This is taking a lot of time. Okay, I'll just add the code somewhere. It should work fine. Canvas.content is not a function. Okay, so here is the error. Canvas dot content 106 canvas.content canvas.content 2D draw image of 00. Okay, let me just check out if it's available in my Gmail. Yeah, I do have this email. I'll just change out the things. Maybe I have done some sort of mistake in writing, or import this one now, and if I run it, okay, over here this is now working fine. This is also displaying me to take the image. Until and unless I take the image, this will not stop loading. And when I take the image will now be converted into a binary code, and that binary code will be encoded, and after encoding it will be taking the image and saving it over here. And if I show you over here you can see I had given the name in the above example like photo.jpg. It should store with the name of photo.jpg. Now we have got the image. Now we will resize, read and display the image accordingly. If I take an variable of image, the cv2 dot imread function image underscore file that we will be I mean the file that we have created. And for this one I want the imutils function to imutils dot, it should resize our image that we have created, image, and it should be of the width of 400. I'm just resizing this one with the width of 400 pixels. And for that I'll be assigning two parameters, height and width. With the height and width I want the image to be shaped, image shaped with the value of 2. And now print the width and height, and we'll allow cv2 underscore imshow to display the image. So if this is going to work fine, imutils dot resize width, what is this, image dot imutils, image not dot equals to imutils. Okay, this is the image that we had captured, and now this is being converted into and resized into 400 into 300 pixel. And now we will implement our cafe model now. So in cafe deep learning, this is one of the deep learning framework where they have, I mean, they have already implemented what is the vector size of the face, width, height, and each and everything. They have trained a huge amount of models in this cafe model. So we will be using that model, and we will be implementing the deep learning face detector OpenCV function. One of the thing that we are going to use in this is SSD. SSD stands for single shot detector, where without wasting any time it will take the single shot, and it will also display how much amount of face is being recognized. Okay, how much amount of face is being detected in the scale of percentage. So for that I have already downloaded it, and for that I think I need to upload those files. Here is one of this. I'll just upload this first, and there is one more file, that is deploy.prototype. So these are the two files that we are going to use, and this contains the uh, model size, models that we have uh, pre-trained for faces, all the things. And by using this, we will be adding this phase, the the detector method, that is single shot detector. So we'll be using this deep learning method, and by using this we will be assigning the values, something like if I say image equals to imutils dot resize of image comma width equals to 400. So this width should be of 400, and I'll take one of the variable called blob equals to cv2 dot dnn dot blob. So here it is, blob from image, and we will resize it now. cv2 dot resize the image comma, will assign it 300 comma 300. So we want that image should be displayed, I mean the above image of mine, this should display the image size of 300 into 300, which is going to assign the value for our, I mean the exact percentage that we will be using. So here I'll be assigning it as 1.0 and 300 comma 300. I'm just assigning the values to this one, comma 104.0 comma 177.0.0. So I'm just trying to assign the values for our image. Now we will pass the blob through our neural network and obtain the detections and predictions. Let me just check out whether this is going to work fine. Okay, let me just add one more code, and from this I'll be printing out our information saying info computing object detections. So I'm saying that if the object is being detected, then it should display print object computing, it is detecting. Then after that we'll be using our net dot set input to our blob variable, where we have mentioned the values for our image resize, and detections equals to net dot forward, and this should be forwarded to us once the detection is being done. Let me just check out. Okay, set dot ipython net dot set input of blob. forward net.set input. Okay, I'll just compute it. Name net is not defined. Okay. Okay, I'll just compute it. First, I'll just complete the code off. Then later on, I can do the things because I have to display one of the starting and ending points of our image, and till where it should find out that whether the image faces how much length, how much width and all. So for I in range of 0, I'll be giving a looping statement, comma, detections dot shape of 2. It should give a shape of 2, and we'll be starting our for, which is we are now going to extract the confidence, that is probability associated uh, with the prediction. We are going to fetch the probability, like what amount of probability it will be. Confidence equal to detections, and here probability will be 0 comma 0 comma I comma 2. This is the probability level that I have given. And if we should also filter out the weak detections by ensuring the confidence. Then after that, greater than and minimum confidence threshold should be set out, so that we can get the proper percentage just by getting the proper probability and confidence. And this can be done by using confidence is greater than 0.5, and we are writing an if statement, and we'll now compute the x and y coordinates of our box, the image box. For the object, we'll be computing that one. And for creating the box, we should have box equals to detections of 0 comma 0. This is again the probability level, 0 comma 0 comma I comma 3:7 into our numpy array, np array of width comma height comma width comma height. So we'll be differentiating it with width height. So these will be the four things from where we'll be computing the rest of the things. And after this, we'll end it over here with one of our start of x. We'll say start of x and start of y, and we'll say end of x comma end of y. So here we need to set out and what should be the integer value for this box dot the type that we'll be using as integer over here. The type will be of integer. Now we'll draw the bounding of the face along with the associated probability. With this, I'll say text equals to dot 2f is the probability, 2f%, and I'll say it should fetch out the percentage also. How much amount of probability of how much amount of face is being matched. Dot format confidence into 100. So we'll be percentaging it with the default value of 100, where it can be saying whether this is a 100% or whether this is a uh, how much percent it is. Y of start of y, where the exact point is going to start, minus 10 if start of y minus 10, then it should be or greater than 10, else this should be of start of y plus 10. So this is the exact way how we are going to find out the percentage. Enter. And to this we will be adding our CV2 now to display it in a rectangle or uh, or any different way that we want, and the image should be now displaying it in a rectangular mode. Start of x, comma, start of y. Start of y, this will be the one thing, and one more thing will be the ending point. End of x, comma, end of y. And this is done. We'll mention 0, 0, 255, 2. So this is the height and width of the rectangle that we are assigning. And one more thing, we need to put the text within the image. We want something like to display the image within the text. Sorry, if I'm trying to write the text onto the image, then I have to go through the image, and either I have to edit it or I can directly put, there is one function that is cv2 dot put text, put text on the image, where image text, comma, where start of x is going to begin, and where this is going to end it with y, comma, cv2 dot font, and font that we will be using, font underscore Hershey underscore simplex. And after that, comma, 0.45 should be the font size, comma, 0, and it should be set on 0, 0, 255. Mm, and this should end at 2. I guess now we will be able to watch out our image. And I'll just run this once. Okay, a lot of errors again. Invalid syntax. Box as type. Okay, one more line. Just one more line is remained. I'll just resolve it. CV2 underscore I am Shona, and this should display the image of mine. Image. So the code is done, and now we'll just resolve our errors and we'll try to execute this one. Invalid syntax. On the line number for I in range. Sorry, I guess I didn't had to do it in this way. I had to actually load the models over here first. Then it would have been working fine. Protext prototext. I can give prototext equals to, here I'll be giving the file name where we will be having the train models, and the model will be of the cafe model that we have already seen, and here I'll be uploading that file cafe model, and to that the error that it was showing net equals to cv2 dot dnn dot read net from cafe, read net from cafe, where we'll be providing proto txt comma and the model, and this should be working from these two models, and these two models are nothing but the files that I have taken. Here is our proto text. I'll just copy this one, copy the path, and I'll paste it over here, and the path of this file which is containing the trained model will be displayed over here. Run it now. Okay, here it is saying computing objects. This is working fine, and over here I should add one more thing. I think I need to take this print Control V, and within this I'll be saying to display net dot set input of our blob, and for this I'll be taking detections equals to net dot forward. Okay, so I guess all the things have been written and working fine. and info computing objects. And if I try to run this, the same thing. Last error, we are up to here and we are about to run our file. Start and end as type. It should be started and it should be an equal to over here. Okay, so I'll just try to run it again with the overall functions. Runtime, run all. Now I'm running it once again so that we can import and get all the images. Okay, you can see it is waiting for me to capture an image, and I'll just capture an image over here. And after this, the image is being displayed with the width of 400 into 300 and all the things computing. Okay, name detection is not defined. Name detections, I guess this is detections, and I think this is it, and we will now display our output. Okay, so here we have, this is the amount of percentage that it is showing, like it is showing 99.99% of the image, I mean the face is detected of the image. If we are trying to if you are trying to add some different images also, we can add our different images, and due to those images also we can fetch out something like there are some sort of images where um, whether something, if you are working in NASA, or if you are trying to work in some ISRO kind of a thing where alien is one of the most I mean shared topic. So at that time, if NASA or ISRO are trying to do such kind of a thing, then they should place this face detector wherever around with the satellites. If any kind of an objects that indicates with the name or with the faces and all, we can directly add I mean we can detect the images directly of the human. Okay, so this is all about the face detection, and I guess I have said a lot of things, and even we got some sort of errors also, but at the end we have removed and tested the uh, all our code cells, and we have executed it successfully. So this is one of the project that, and I guess time is not permitting me to implement one more project. Actually, I had planned for two projects in today's session, but the time went so quickly so that I could not cover up the things in a very short time. And I'll be sending the code um, to Gururaj sir directly. Gururaj sir, sorry, Guru Prasad sir.
Yes, sir. Yes, sir.
So I'll be sharing the code with you directly. So you can share the code, and even I'll be sending the text um, as well as the model that we have trained. I'll be sending you on WhatsApp, sir. So or I'll be mailing you. You can just
Yeah,
share
yes, sir.
the
You can send me
response.
in WhatsApp as well as mail me out.
Yeah,
So I
yeah,
will
sir.
be sending it to all the participants once I receive it.
Yes, sir. I'll be just sending you just after the ending of the session itself.
Okay.
So, if any doubts regarding this project, uh, I'm here for that.
So I request all the participants, if you are having any doubts, you can unmute yourself and ask the question to the resource person. Is any participant with questions? So this is lively explained by the Abdul Rahim sir. So on face detection. So if any participant is having query, so they can just still ask the Rahim sir, or else you can even put it in the chat box. Hello, Dhananjay sir, are you there?
Yes.
Yeah, sir. So sir has covered the face detection with machine learning using Python. So one of the project has been implemented. So if any participant is having the doubts, they can just raise the query in the chat box or ask personally to the Rahim sir. I hope there is no query from the, this means there is no query from the participant end. So
Yes, sir.
yeah, so we can go for concluding the session.
Yes,
So
sir. We
still,
can.
yeah, still 5 minutes of time is there. So if you
Yeah,
want
yes.
to ask anything from the resource person, so it's an open forum. So you can unmute yourself and ask the things.
A lot more things was also up to cover for. I wanted to cover, sir, but just because of time, I couldn't make it. And one more implementation will be on my side,
Okay.
and we'll be working with image processing because I wanted to show image processing, which is widely used um,
Yeah, yeah.
in the world.
So yeah, sir. So next session we can go for it, sir.
Yes, sir, surely. I'll be having the image processing session next time
Okay, sir.
with
So
the
the
DIP,
yeah,
digital image processing, sir. We'll go with that.
okay, sir. No issues, sir. So with this note, so as there are no queries from the participant end, so I thank Abdul Rahim sir for giving his valuable time and more insight on how to develop a project on face detection using machine learning. So that was really a lively performance, which we have not thought of it. So it was really a wonderful session, sir. We could not forget this one because doing the live things directly is not so easy. So I really appreciate and acknowledge you from the bottom of the heart from CSC department. So this was really a wonderful session, and there are many more to take away from you from the upcoming sessions. Thanks one and all for your patiently listening. uh, Thank you one and all. So with this note, I sign off today's session and will end the session. Thank you one and all.
Thank you, sir. Thanks a lot.
Yeah, sir. So we will meet in the next session, sir. Thank you.
Okay, sir. Okay, thank you.